Hello, let's now discuss how can we solve this problem. So minimum capacity box, that's the problem number one in today's weekly contest 492, right? So let me check whether my voice is it audible. Yes, wait a second. Let's wait for some others to join this live session, right? Yeah, let's read the question first. You are given an array, integer array capacity, where capacity I represents the capacity of the ith box and an integer item size representing the size of an item, representing the size of an item, right? Now, return an integer denoting, so if you see the ith box can store the item if capacity of I is greater than or equal to item size. Now, what we have to do is we need to return an integer denoting the index of the box with the minimum capacity that can store the item. If multiple such boxes exist, return the smallest index. If no box can store the item, return -1. What do you understand by this question? Right? Anyone can answer this. So, what is the first thing which you realize about the problem? That's an easy problem. We can do that in one go. But before going to that, let us see the constraints before going to the examples. Right. So the constraints are one less than capacity dot length less than or equal to 100, one less than or equal to capacity of I less than or it all are in the at the max of 100, right? Now let's look at the examples first. 1 5 1 wait so 1 and 5 3 and then 7. This is the capacity given, right? Now item size is 3. Now if you see, is 1 greater than or equal to item size? That's what I need. Capacity of I is greater than or equal to item size. Is it true or not? Right? 1 is less greater than or equal to 3. It is not true. 5, is it greater than or equal to 3? Yes. 3, is it greater than or equal to 3? Yes. 7, is it greater than or equal to 3? Yes. But if you see, I need minimum capacity that can store the item. If multiple such boxes exist, return the smallest index. So let's just see, look at what is the minimum capacity which I can get. So 5, 7 and then 3. From 5, 7 and 3, 3 is the minimum, which is greater than or equal to item size. So that's why I don't return 3. Instead, I return the index, right? Here, the index 0, 1, 2, and 3. So I would return 2 here. That's it, right? If I just returned 2, that's our answer. Now, imagine, just imagine it is placed like this: 1, 3, comma 3, 5, 2, comma 7, and the item size, this is the capacity, and the item size is given as 3 again. Now if you see, let me tell you here, I have 1. Is 1 greater than or equal to item size? No. So capacity of I should be greater than or equal to item size. And from all of that, I need to get the minimum. So 3, is it greater than or equal to item size? Yes. 3, is it greater than or equal to item size, which is 3? 3 is greater than or equal to 3, right? So yes. 5, is it greater than or equal to item size? Yes, 5 is greater than 3. 2, is it greater than or equal to item size? No. Item size is 3, but the capacity is 2. Now 7, is it greater than or equal to item size? Yes, but again I got the same values. Here the indices 0, 1, 2, 3, 4, and then 5. But what are the values that I got are 3, 5, and then 7. 3, 5, and then 7, right? So from this, the minimum capacity, they asked us the minimum capacity. Yes, the minimum capacity is 3, right? I would return the index where 3 is. Here it is 2. But if you see, that can store the item. If multiple such boxes exist, there are 2 boxes with 3 capacity as 3, which is nothing but the minimum capacity. So what we would do is return the smallest index. Here it is. We need to return the smallest index. Here the smallest index is 1. So we will return 1. Let me tell you one thing. So I need minimum capacity and also minimum index which is smallest, right? So what would be the minimum capacity initially? So they said 100, but let me take the minimum capacity as int max, or you can call it as infinity. Now the minimum index would be n minus 1, where n is equal to capacity dot size, right? So n is capacity dot size, nothing but the size of the array. Minimum capacity is int max, and the minimum index I am saying it as n minus 1. Now let us do a dry run on this. 1 3 3 5 2 7, right? Let's take the array again. 1 3 3 5 2 7. Now what I'll do, I'll just compare. What is my intuition or what is my thought process is, if you see, I have a 7 which is lesser than the int max. So let me take this as uh, my lesser, minimum capacity. But if you see, I should not only check the lesser than the minimum capacity, right? I should also check whether is it greater than or equal to item size, right? So I need to check that too. I need to check whether is it greater than or equal to item size, and also whether is it lesser than minimum capacity. I'll tell you how. So is it greater than or equal to item size? Yes. So what I'll do, I'll consider this. So I'll consider 7, but not 7. Instead, I will store 0, 1, 2, 3, 4, 5. 5 as the index which I want to return. Now let's go to 2 here. Let's go to 2 here. Let me change color. Here I have 2. So item size as they have given, it is 3. So is the capacity of I, is it greater than or equal to item size? No. 2 is not greater than or equal to item size, right? 2 is lesser than the item size. So I won't consider it even for changing the index, right? So now I got 5. Is it greater than or equal to item size? Yes, it is greater than or equal to item size. right? Now, if you see 5 is lesser than 7, which is minimum capacity, right? So every time what I'll do, every time go to element, check two conditions, whether the capacity of I is greater than or equal to item size, and capacity of I is greater than or equal to item size, and the capacity of I is lesser than the minimum capacity. So the capacity, so previously this will be our minimum capacity, right? This would be our minimum capacity, right? But before that, before even 7, the minimum capacity would be int max, right? So I'm just comparing it with 7 and also making sure that capacity of I 7 is greater than or equal to item size, greater than or equal to 3. So, and also capacity of I is lesser than or equal to minimum capacity. Why equal to? Why I'm saying equal to, I'll tell you. If these two are, satisfied, then minimum capacity will be capacity of I. And what about the minimum index? It will be changed to I, right? So the minimum index is changed to I. Now I am saying capacity of I is less than or equal to minimum capacity. I'll tell you why. Now if I don't have here the minimum capacity at this time, will be 3, and the minimum index will be 2, right? So the minimum capacity is 3 and the minimum index is 2. Now if I don't have this equal to, just equal to capacity of I is less than or equal to minimum capacity, when I go to this index 1, here 3, is it less than or equal to minimum capacity? Yes, capacity of I is less than or equal to minimum capacity. But if I don't take this capacity of I equal to, I would just compare which is lower, right? Which is lower, nothing but it won't go to the item size, exact item size. It won't go to this 3. It would skip this 3. If I just wrote capacity of I is less than minimum capacity, it would be false and we would not get the correct answer. Instead, we would get 2 as our answer, right? So the so the capacity of I should be less than or equal to the minimum capacity, right? So here at the time the minimum capacity is 3 and previously the minimum capacity is also 3, right? Minimum capacity is equal to the item size, right? So if I don't write equal to, I would just missed the index, the actual answer, which is 1. So if these two meets the requirement, I would just change the minimum index and at the last I just return minimum index. I just got, I think, yeah, mini is nothing but int max and minimum index is equal to n minus 1. Let's do it right here. Let's do it right before going to the code, right? Let's just take the same example, 133 527. 133 527. 133 527. Now I won't go from the beginning. I would go from the end, right? Now if you see, for I is equal to n minus 1, I is greater than or equal to 0, I minus minus, right? So let me go in this way. Here is our iterator, I is here, and the minimum index is equal to, what is n minus 1? Let me check. 0, 1, 2, 3, 4, 5. So the n minus 1 would be 5. And what about this mini or minimum capacity is int max, right? Now I is equal to n minus 1, I is greater than or equal to 0, I minus minus, right? So first I am at this position. If capacity of I is greater than or equal to item size, so the item size is 3, right? Now if capacity of I is greater than or equal to item size, is it true? Yes. 7 is greater than or equal to 3. And capacity of I is less than or equal to mini. Minimum capacity here. Is capacity of I is less than or equal to minimum capacity? Yes. So what I'll do, mini is equal to minimum of mini comma capacity of I. So I just change it to minimum of 7 comma int max, which is nothing but 7, and minimum index is equal to I. So the I is 5 itself. So I'm just again changing it to 5. Now let's go to the next uh, position. So iterator is here. Now is this 2 greater than or equal to item size? Item size is 3. So 2 is greater than or equal to 3? No, it's not. So what I'll do, I'll just skip it. This condition is false, right? This condition is false. So I'm just going to the next one, right? I'm just going to the next one. Now let me go. Here 5, right? So if you see here 5, is it greater than or equal to the item size 3? Yes. So capacity of I is less than or equal to mini. Is 5 less than or equal to minimum capacity? Yes. So what I'll do, I'll just check 5 and 7. What is the minimum? I'll 5 and 7, the minimum is 5. So I'll just change it to 5. And what is the minimum index is equal to I. I'm just changing the minimum index to I. I is 3. So I'm just changing it to 3. Now I'll go from here to here. Now if you see, is 3 greater than or equal to item size 3? Yes, it is equal to item size. So what I'll do, capacity of I is less than or equal to mini. Capacity of I 3 is less than or equal to 5. Yes, of course. So what I will do, I'll just change minimum is equal mini is equal to minimum of mini comma capacity of 5 3 comma 5. The minimum will be 3 and minimum index is equal to I. I'll just change the minimum index to 2. Now I'll go to the next index 1, the previous index. I'm going from the right to left. Now if you see this 3, is it greater than or equal to item size? Yes. Is it less than or equal to minimum capacity? Yes. So what I will do, I'll just change minimum is equal to minimum of mini comma capacity of 5 3 comma 3. Again, let me change it for better understanding. So I'm just changing it to 3. Minimum index is equal to I. So I'll just change minimum index to 1. Then the last iteration here 1. So is 1 greater than or equal to item size? No. Right, item size it is not greater than or equal to item size, so I'll just skip it. So what is the minimum index I'm returning? 1. That's sorted, right? So we can just take the minimum index from here, so it would work better, right? So that's how we got accepted our first problem. Let's go to the second problem here, right? So let us just be clear how we got it, right? So our our target for for this live stream will be 1,000 subscribers, which is lesser than right 60, which is lesser than 100, right? So we got 943 subscribers. We just need 57 more. We just need 57 more subscribers to hit 1000 subscribers. So I hope we reach our target by end of this session. Let's go to the second second problem in today's LeetCode Weekly contest. So if you see, we are given an integer array nums and I is balanced. If you see, so the left is considered as the sum, the right is considered as the product. So when I am at the index, I need to take the left sum and the right side product, right? So if the left sum and the right product are equal, then I would consider the index as balanced index, right? Now, how can we solve this problem? Maximum possible sum. Maximum possible sum would be something like 1 if 14, right? It is just something like, if you see the constraints, 1 if 5 into 1 in 9 is nothing but 5 plus 9. A power b into a power m into a power n is nothing but a power m plus n is nothing but 1 if 14. For int I is, it is just an easy problem, the prefix sum problem, but what we need to make sure is the runtime error. That's it. So uh, total sum plus x. Okay, what do you think about this problem? We got just 943 subscribers. I'm just looking at this subscriber count, right? So let's go to the problem, actual problem, right? So let us concentrate on the problem, right? Okay, so firstly, what they have given us, given what we have given with, first you're given an integer array nums, and index I is balanced if the sum of elements strictly to the left of I equals the product of elements strictly to the right of I. When I am at this index I, the sum here and the product here are equal, right? They both are equal. Then we can say this index as balanced index, right? Now there is something like, what if the index is 0 or n minus 1? What if I am at this position? What if I am at this position? So for this, the left sum is equal to 0. For this, the right product is equal to 1. So if there are no elements to the right, nothing but the last index, the product is considered, the right side product is considered as 1. Now, if there are no elements to the left, the sum is considered as 0. The left sum is considered as 0. Return an integer denoting the smallest balanced index. If no balanced index exists, return minus 1. It's a quite simple problem, but the only problem with this is the runtime error. I'll tell you how I computed it. Let me tell you one thing. Let me write it. If I compute, if I compute the product of every element unnecessarily, I'm saying it as unnecessarily. I'll tell you why it is unnecessary. I go to runtime error. I'll tell you. Let me just do that. Now let's create an array first. Let's create an array. So int is equal to nums dot size. Now let me create vector of int. So vector of int products with wait a second. Yes, products of size n. That's it. Now products of n minus 1 would be 1, right? Now for int I is equal to n minus 2, I is greater than or equal to 0, I minus minus products of I will be equal to nums of I into products of I plus 1. Let me tell you how it works. Let me take a simple array like this 2 1 2. I need to take 2 8 double 2 5. 2 8 double 2 5. Now I am creating an array products where here the product is 1. Now if you see for wait a second, for this 5 the product here it should be 5, right? Yeah, it should be 5. Products of n minus 1 should be nums of n minus 1. That's a mistake, right? So the products will be 5. Why? Because after this element, the product will be, after this element, the product will be 5 itself, right? Okay. Now, what about this element, n minus 2? For this, the product will be from here to the end, 5 into 2. Nothing but 5 into this element. 5 into 2 would give me 10. Now what about 2? Instead of going from 2 and then 2 and then 5, if you see, I have 5 into 2 stored in products of I plus 1. Here if I say this as I, now, what I'll store at products of I is nothing but nums of I into products of I plus 1. That's it. That's what I stored here. Nums of I into products of I plus 1. Nothing but 10 into 2 is 20. Now, 20 into 8. 8 2 16, 160. 162. 16 to 32. That's it. 320. Right. 320, 160, 20, 10, 5. That's the products. Now, if you see, do I actually need this 320? Do I actually need this 160? Let me tell you. Why? Because the maximum sum which I can get, I said here unnecessarily, the maximum sum which I can get is 2 plus 8, 10 plus 2, 12, 2 and then 2 and then I got 10, 10 plus 2, 12, then I got 2, 14, 14 and then 5, 19. So if it is already exceeding 19, that's the maximum sum which I can get, right? 19 is the maximum sum which I can get. Now, how would be the product which is greater than, let me write, how would the product greater than maximum possible sum would be equal to some prefix sum, pre-sum. Let me say that as pre-sum. I'll tell you how. Here I got 19, right? Here I got 19 as the maximum sum. So till here, even if considering all the elements, I would not exceed 19. But if you see, the product is exceeding 20. That means I do not need this product. I do not need this product, right? So I'll just stop at that time. I'll just take this and let me explain you this clearly. So the products of I is equal to nums of I into products of I plus 1. What I'll do for int I is equal to, wait, 1 I is to 1 I is less than n, I plus plus. So nums of I plus, wait a second, nums of I plus is equal to nums of I minus 1, right? Nums of I plus is equal to nums of I minus 1. Let me tell you, 2 8 double 2 5, right? 2 8 double 2 5. Now I'm saying 8. So 8 plus 2 would be 10. 2 plus 10 would be 12. 2 plus 12 would be 14. 5 plus 14 would be 19. That's it. That's what the prefix one would be. Now I is equal to 0. I would go from like this. If I is equal to 0, int presum or lsum is equal to 0 and our product will be equal to 1. Now if I is equal to 0, lsum is already 0, and if right product, what about the right product? The right product will be products of I plus 1. That's it. If right product is equal to left sum, then just return I. That's it, right? Now, if I is equal to n minus 1, right product is already 1. Now, what about the left sum? Left sum is equal to nums of I minus 1. That's it. Now, if left sum is equal to right product, return I. That's it. Now, uh, is there anything which we got forgot? Nothing. I is equal to n minus 1. We do this. Return I. Right? Now, if not, left sum would be nums of I minus 1. Right product would be products of I plus 1. Right? So if L sum is equal to right product, then return I there itself. If not, return minus 1. Let me just check this. Now I have given offset. Let me just copy this. If you have any doubts, please let me know in the comment section. Or uh, let me tell you here, instead of vector of int, let me take long log. Now it's giving me a wrong answer. Okay. One long log. Now here, long log again. No. What error I have did here which gives me a runtime error? I think I have not long of long products of n. Okay. Is the error here? No. Nums of I into products of I plus 1. Why is it giving me? anyone knew why I am let's see, getting this error, please let me know in the comment section. Now let me see whether which loop is giving me the wrong answer. No error 1, no error 2. Okay. I is equal to n minus 2, I is equal to the number is equal to no error 3. But when it is here, LL into no, I got an error again. It's equal to 0, it has run. But there is a problem here. If I is equal to 0, right product is equal to products of I plus 1. Okay. Right product is equal to left sum return I, which is 0, I is equal to n minus 1. Okay, I came to know that the error is in this loop. Let me check how is this an error. Error 1. Yeah, right product is equal to products of I plus 1. Is the error caused here? One long should I say that as products are also no, error 1. Why is it giving me an error here? Right product is equal to left sum return I. What does this error unsigned offset to? Addition of unsigned offset. Wait. I know it gives me an error. Terms of I into products of I plus 1. Okay. Got to have this first submission here, right? This one, prism of 5 minus 1 plus terms of 5. Here I got it like this, current sum and product. So if you see, if the product is exceeding 1 if 14, that's the maximum which I can get, right? So I'm just creating the product is equal to 1 if 14 plus 1, right? But it is not needed. I is equal to n minus 1. We got this pre-sum. Let us take this. We got this product, right? But there is an error here. I'll tell you what it is. Runtime error for this test case at 53 by 907. Let me tell you here. Here there is a runtime error. Signed integer overflow cannot be represented in type long. We cannot store it in long, I'll tell you. So what is the thing which I got to the end? The last intuition is why we have to go to the why we have to consider the product which is greater than maximum total sum. So the maximum total sum is 19, right? So we need pre-sum or L sum is equal to right product. If the right product is exceeding, if it is already exceeded the maximum total sum, why we just need to compute it, or why we need to consider it, right? So that's how we got the last one, the last solution, right? So it would be taking much time if I just type all that. So for first thing is a suffix product is nothing but the array, right? Now if you see, just I think we just don't need this, right? We are just creating suffix product. Yeah, yes, here suffix product of I. Okay, now let me tell you how it works. If the current product is greater than maximum possible sum by nums of I, if it is greater than maximum possible sum by nums of I is nothing but we are dividing the maximum product by the current element, then if it is exceeding, then we just take the current product is equal to maximum possible sum plus 7. Here the maximum possible sum is 114. Now the total sum is x, right? So the maximum possible sum could be 114. That's the maximum product that we can get, right? Else we just say the current product into is equal to nums of I. Now we just take left sum is equal to 0 and we compute left sum plus is equal to nums of I. If left sum is equal to suffix product of I, we are just storing every element to itself suffix product of I. So suffix product of I is equal to current product, and if current product is greater than maximum possible sum by nums of I, we just change current product to maximum possible sum plus 7. So that's how you compute this one. That's, let us see whether everyone has submitted it. Find the smallest balanced index. Let me go to LeetCode problems. I hope you understood. We'll be having this uh, session every week on these contest problems. 3862. Okay. Let us look at some solutions so that we can see whether we can optimize it or not. So there will be people one pass trick to find the smallest balanced index. For each index I, we need to check two things: sum of elements on the left side, okay, product of elements on the right side of I, okay. If both values are equal, yes. Instead of recalculating the left sum every time, we store prefix sum so we can get the left sum quickly, okay. That's just the prefix sum array. We are just creating the prefix sum array. For the right side, we keep multiplying elements while moving from right to left. So we are just moving from right to left. First compute a prefix sum array, okay, then traverse the array from right to left coming from the end, and maintain a variable product which store the product of elements on the right side. Initially product, because if there are no elements, okay, the prefix of I minus 1, then product on the right is product. If both values are equal, then I is a balanced Next, after checking, update the product by multiplying nums of I. Since we traverse from right to left, the last valid index we store will be the last smallest balanced index, right? So if no such index exists, yeah. So they used unsigned long log. Okay. If product is greater than prefix sum of n minus 1 break. Okay. So he initialized answer is equal to n minus 1. Prem Kumar. Okay. Answer is equal to minus 1 and n is equal to dot size. Vector long prefix sum. Okay. Prefix sum. Then long. Okay. So if the product is greater than prefix sum of n minus 1, that's the simple intuition, right? Instead of having all this, let me tell you. Let me tell you what he did. He did answer is equal to minus 1 and he got the product is equal to 1. And let me initialize vector of long pre-sum of n. Right. Now let us just come from the end, but before that, for int I is equal to 1, I is less than n, I plus pre-sum of I plus is equal to pre-sum of I minus 1 plus the current element I. Now for int I is equal to n minus 1, I is greater than or equal to 0, I minus. If I is equal to n minus 1, as we know, product is equal to 1, right? So what we will do, if pre-sum of I minus 1 is equal to product, we just return. Do we have to return? No. We just need to change the answer to I, right? If not, we just continue from here. Now, if you see, what about the product? Product into equal to nums of I. So if the product is greater than nums of n minus 1, then we just break it. Now we got the product, right? How we will we'll just compute is if pre-sum of I minus 1 is equal to product, then answer is equal to I. We just return our answer here. Let me check whether do I have any errors here. Okay, pre-sum of n then is equal to nums dot size. No, we got an error again. So here unsigned long. We got an error again. Please remove it. Okay, I is equal to n minus 1, I is equal to r is equal to 0. I minus. I think we got missed at somewhere, some point, right? Someone, okay. So if you have any doubts, please let me know. Wait a second. Right, so what is the actual error we are doing here? This is subscriber count. We just need 54 more subscribers to hit 1000 subscribers today, right? If I is equal to n minus 1, I will do that. I is equal to 0, then be sum of I minus. Here, where is this test result? Here, if I is equal to 0, if products, not products, product is equal to 0, then answer is equal to I. Then we just continue. Right? No, we got another okay. Wait a second. If anyone knew how we got this runtime error, I is equal to 1, I is less than n minus minus. We have initialized answer is equal to minus 1 and n is equal to nums dot size. Long pre sum of n. Pre sum of 0. Pre sum of 0 should be nums of 0. Right? Okay, pre-sum of n we have created, and we have created unsigned long product is equal to 1. Is there anything which I am missing? Pre-sum of I is equal to also of I plus no, pre-sum of okay. We are just using plus is equal to okay, right? No. Unsigned long if I is equal to n minus 1 I is greater than or is equal to, let us use this is equal to 1 I minus 1. If prefix sum or pre-sum of I minus 1 is equal to product, answer is equal to I. That's it. As we are not going, if we go to n minus 1, already the product is equal to 1, right? So we just don't need to uh, compute it again. Now if product is greater than nums of n minus 1, nothing but the maximum sum which we can get in the array, right? So if you have any doubts, please let me know. Wait a second. If you have any doubts, can we do, wait a second. Uh, can we do it with second matrix? Quotient reminder. Quotient and reminder, right? Which problem are you talking about, Pranay? Which problem? The first one or the second one? 2D matrix, I think we just don't need any 2D matrix here. We can just use the prefix sum and the suffix product, right? So if we just knew the prefix sum, here we already computed the prefix sum, right? So I just don't need these all things, as already if I is equal to 0, we just don't get that. So what we'll do, let me know Pranay, which, okay, here, let me take, we got a runtime error at this point. Okay, let me run it again. No, we got an error here. Output is -1, but expected is 5272. What's wrong in this? Answer is equal to -1 unsigned long if um, It's a long test case, right? It's a big test case. What exactly the problem here? I can't, if product is greater than, sorry, here it should be pre-sum. Let me check now. Pre-sum of n minus 1 instead of nums of n minus. That's just the variable mistake, right? So what do you think, right? Yeah, it ran in just 5 milliseconds with 88.79. Let me know, Pranay, which what about what is I couldn't get you. I didn't get you. What is about the quotient and remainder, and let me know which problem you are talking about. Let's go. This problem I couldn't solve. Minimum operations, right? Minimum operation I couldn't solve this problem. Please let me know if anyone in this live stream have solved this problem, right? Or have any hint. Let me check the hint. Second question. Okay. What is about the quotient and remainder? What is this quotient and remainder? Right? I didn't get you. Why we need the quotient and remainder? Let me tell you. If you create a 2D matrix here, 2D matrix here would take you 1e5 into 1e5. Uh, that's the matrix size, right? 1e5 into 1e5 would be 5 in, it would be 1e10, I think. 5, no, 2 2 is 4, something like 5 into 5. If it is 9 into 9, we would get 81 cells in a matrix. It would take 1e5 into 5 would be 1e25, right? Which is 1 and place 25 zeros after that 1, right? So no, we cannot go with the matrix. Let me know what are you talking about the quotient and also the remainder. Let me know about that in the comment section, right? I go with any other approaches, or even if it is optimized or not, it doesn't matter. I think it is not possible. Yeah, let me know what you quotient and reminder, right? Shall we move to the third problem, or you have any doubts on the second one? Let me know, Pranay. Everyone in this live session, please let me know. Do we should we go to the next problem, or do we have any optimized approach for the second problem? Shall we go to the third problem? Yes, please let me know. I think we should get 947. That's the live count. We need to get 53 more subscribers. Someone has sent me a request in LinkedIn. Right, I think it's not possible. Transfer university. Okay, okay. Let me. So this. Let me check my ranking. I think it would be around. Okay, okay. 8,289. Let me know your rank, the global rank. Let me know your global rank in today's contest, LeetCode contest. Yeah. So I think your doubts are clear. Let's go to the third problem. Right. So let us see what's the live count. 947. Just need 53 more subscribers today by the end of this session to get 1000 subscribers. Now, minimum operations to sort a string. That's I just need some hints to solve this. Okay. Okay. Is there anything which I missed? Minimum operations. If you knew how we could solve this problem, please let me know. I didn't even. I just attempted it. Three wrong answers. I got a wrong answer for 3 times. That's the first time. J, G, and then G. That's the first wrong answer, and then I got again EDC. Then I got again for SRRP. Let me know if anyone has solved this problem. Find the okay, this one. You are given a string S consisting of lowercase English letters. Now in one operation you can select any substring of S that is not the entire string. So we should not select entire string. We just need to select a substring, right? We just can't select the entire string. As you can see, is the clarity, is it wait, can you see the screen clearly? Okay, in my mobile it's clear. Okay. No, no. That is not the entire string and sorted in ascending alphabetical order. Return the minimum number of operations required to make Kalyan bro. Yes, we can just go to the yes. You have solved it. Let me know your approach. I'm just trying this and I just went with two things. Firstly, if it is already, let me tell you the last submission. This is the last submission. This is my last submission here. If I'm just sorting, I'm just taking the sorted string. No, if it is already sorted, I'll just return 0. Now, if the string size is 2 and it is already not sorted, right? We cannot take one character and sort it. We can just take two characters and then sort it. Now if the string is already two characters and it is not sorted, we cannot do that, so we just return -1. Now if s of 0 is equal sorted of 0 and s of n minus 1 is equal sorted of n minus 1, return 1. I'll tell you how. So the first character and the last character are already sorted. Let us take an example. First character or the last character. Let us take DOG. Now, if I just sorted D, A, B, C, D, F, G, H, I, J, K, L, M, N, O. So the sorted is DGO. Now I'm just placing D here itself. And what about the OG? I'm just changing it to DGO. That's it, right? DGO. That's it. So in just one operation, by just selecting the substring which doesn't contain the first character, I'm just getting a 1 as the output. But when I get 3 as the output, I need to know. What about card? Wait a second. I need to look at this point. If you have solved, please let me know. I didn't solve it. So what is this? Card. Now the sorted is equal to A, C, D, and then R. Now these two are not equal, these two are not equal, these two are not equal, these two are not equal. When it is okay, JGG, EDC, JGG, EDC, SRRP, JGG, right? So ABCDFG, G will be the first character. Now for this we expect two operations, G, G, and then J. Okay, okay. How can we, what we can apply here? EDC. So the sorted here is equal to A, B, C, D, E, right? So I just do the first one like this, D, E, and then C, then the second C, these two, D, C, E, and then these two, C, D, E. So the first it is EDC, then DEC, then DCE, then CDE. That's it, right? That's the three operations. What about SRRT? We need three here also. We need three here as PQRS. If it is decreasing, I think no. Okay. We got SRRP, right? So P, R, and then S. If I just sort these three, I would get R, R, S, and then P. If I just sort these three, P, Q, R, S, P, Q, R, S, and then here R. If I just sort these three, R, P, Q, P, Q, R, and then S. So SRRP first, second, and then the third. But what error I got here? When we take this test case, okay, let me submit it. GGG output was 3. Okay, let me write a test case here. JGG, right? JGG. City of G, H, I, J. No, there are three possible ways. C, B, A. For these three, if they are not sorted, let me tell you how it works. A, B, C, right? So these two I need B and C, and then A. These two I need B, A, and then C. These two I need A, B, and then C. So 1, 2, and then 3. But if I have only 2 character count, but then A, C, B, how many does this need? A, C, B. So we just don't need A here, just need C, B here. First thing, if S of 1 is not equal to S of 0, and also S of 2 is not equal to S of 1, then let us look at the hints first. First, okay, I know. Let mn be the minimum character. If mn appears at the beginning, not whole string, max appear at the end, not whole string. Answer is 1. Okay. First, and cannot be okay. If no mn exists in any proper prefix, and no mx exists in any proper suffix, answer is 3. Uh, okay, let's remove all this. Wait a second. Instead of we are uh, we are returning 1 here, right? If no mn exists in any proper suffix, what does this proper prefix and no mx exist in proper suffix mean? So let us take that. Are seen as mn is equal to minimum of mn comma mx. Sorry, c mx is equal to max max comma c. Now character mn is equal to z, mx is equal to a. Now if as okay, mn be the minimum character, be the minimum. If mn at beginning, mn is equal to s of 0, or mx is equal to s of n minus 1, return 1. If s cannot be transferred, okay, if no mn exists in a proper prefix, I don't know how to do that. How we can return 3? 3 is a surprise. Okay. This question first one. one and only, okay, one and only largest character at first. If mx is equal to s of 0, ampersand ampersand s of 1 is not equal to mx first, and one and only smallest character at last. Uh, is equal to s of n minus 1, and mn is not equal to s of n minus 2, then we would return. Somehow it might work. Yeah. But what about j, g, g? Yeah. So we just, I think we can, no. What does this mn? These questions like this, yeah, they take that. Let us look at the solution. It is taking much time. The ends are equal, but the solution. That's an easy simulation, but let us see. Just take like this. Sorted is not as good as. Hi, bro. Raghu, Raghuram, right? Your name is Raghuram. I'm a beginner just starting DSA aggressively. Give me any suggestion how to motivate myself when approaches are not clicking. Bro, you can follow me in my Instagram, right? So the Insta ID is underscore R underscore S underscore S 11, right? You can message me there, or you can find me in LinkedIn. You can just message me. I'd be giving you every guidance which you required, right? In LinkedIn, you can search for this. In Instagram, let me check. For Instagram, this is the ID, and I won't be giving the mobile number, right? Okay. So these two, you can just message me there, and you can ask any question or any doubt. So let us keep this to solving problems. Sorry for not answering you due to the time constraints. If sorted is equal to as return 0, and we just return minimum of process 2 of as. Okay, Ragram bro. So yeah, I think it's a clear problem, but it is not the optimized approach. I think we can solve this like, wait. Okay, smallest is equal to z. Okay, we are just fixing smallest and largest. Okay, that's a clear approach. Okay, let's keep it like this, and we will be solving this. Meeting you again on next Sunday, or even this March 14th for bi-weekly contest. It's not fixed, right? I might create, come to the live stream again on March 15th of this, for this weekly contest 493. So please please make sure that you come on time. It would be around 9:30 to 9:45. So thanks for watching this live stream. Just need 53 subscribers, but 51 subscribers, but it's okay, right? I'm just ending this live session. So this is my Insta ID and also my LinkedIn profile name, Ragipani Sai Sidhu. So you can just go there and ask me your doubts. That's it. Meet you next Sunday. If you have any doubts, please let me know in the live chat. I'm looking at the live chat in my mobile, don't worry. We'll be ending this in 2 minutes. We'll be ending this live session in 1 minute. If you have any doubts, we can extend the live session. If you have any doubts, please let me know in the live chat. Right. That's what's the analytics. Yeah, bro, Ragram, bro, sorry for not clarifying your doubt. So it would take a much time. That's why I didn't got you. We couldn't able to solve the third problem, and we didn't even try the fourth one. So I need to do the TSA aggressively. So yeah, we'll be ending this session. Thanks for watching my session, right? 11:10, it's already 11:10. Okay.